will jump over this. So yes, please see that we are starting here. So if one of my colleagues could maybe post in the chat the link to where we are. Okay. I can do it as well.
No, I'm trying to do it. It's just that it was not behaving well.
Yeah. Meanwhile, I can tell you that I'm Björn Claremar. I'm at UPPMAX in Uppsala. And with me today, we have Pedro and Birgitte from HBC2N. And so we are from different NACE centers, you could say. More about this later on. So we come from different centers where we have different clusters, and they work a little bit differently. There are many similarities between these clusters, but there are some differences, and so we will have separate sessions in the afternoon where we have where we go more, where there are quite large difference between the centers. So you who are using Kebnekaise can go there, and you who are using UPPMAX can go to our to my channel, basically. Yes, Fredrik, well, we are recording, so if you don't want to speak, it's okay. We have the chat.
I just wanted to know, I'm using KTH for my computation. Should I then go to the Uppsala or the Umeå center? Which one is closest?
It doesn't matter the closeness, but yes, this is quite important information. After the new year, both UPPMAX and the Rackham and the Kebnekaise, which it is now, they are local clusters. So only university affiliated researchers can be there. That is for the PI, I think. So if you at KTH have collaborations with the people at Uppsala University, I think you can apply for projects also on UPPMAX. But otherwise, we have Dardel at the PDC. That is basically KTH. And we have also in Linköping, NSC. I think those are the two that will be open also after the new year. Please correct me if I'm wrong.
I believe those will be, yes. And I guess at that point, we will probably move this course to run on Dardel, I think.
Yeah.
But there are not that big differences. So, I mean, what you learn here should be applicable, most of it. It's minor differences.
Yes.
Mainly in naming and things.
Okay. Yes, general information should be true also for other HPC centers, more or less. Okay. We expect that you respect each other during the course. And yeah, of course, you know all this. So we can jump to this. Yes, let us know if the volume is too low or something like that, so your learning experience becomes as good as possible. So let us know if you have any problems. Okay. We have the Zoom, and yes, we will also have a Microsoft collaboration document, which should be used for the questions and answers. So now I clicked this, and I hope you have found this as well. It takes a while to load, but here it is. So today is Wednesday, so if we scroll down a little bit, we will come to the Wednesday part. Yeah, so here you can see the questions from yesterday. So the good thing with this is that it is, yeah, you can reach it after the course, so you can go back if you have any troubles. You can go back to this document, even though you didn't have these questions right now. I mean, yeah, so this becomes part of the documentation of the course, basically, because it expands the content, basically. So here on page 7, here we have the Julia-Day and some useful links. And here we have the question and answers. Here are some project IDs, for instance, and directory name on Rackham, and this is for HPC2N. During the course, if you're a little bit uncertain what to type, you can go back here and copy paste these ones. So depending on what system you're using. Yes. Okay. I hope you have gone through the pre-requirements, because then it is much more easy to follow. So having a terminal or thin link set up would be very good. And yes, having some familiarity with the Linux command line is very nice. Otherwise, we are here to help you. So you can post your questions, as I said, in the Q&A document. And my colleagues will help you. There is also a Q&A inside the Zoom. And it's interesting to see that you start to use it. I saw it the first time yesterday that people are using it a lot. And what do we think about that? Birgit and Pedro, is this a good channel as well, or should we keep inside the shared document?
I think mainly it is better to stay in the shared document, but we can do I mean, it also depends on how many people are using it, I guess.
Mm-hmm.
So,
okay.
I mean, if there aren't that many, then yeah.
Mm-hmm. Okay, good. Yes. Yeah, so this course is not about improving your programming skills. So there are other courses. So here's a link for from the pre-requirements. I will make my screen a little bit bigger. Oh, yes. So here's a link. So rather than this course, you will learn how to understand the ecosystems and the navigations for the different languages on a HPC cluster. So mainly how to run your program and how how to develop your code. Yes. So what is a cluster? Basically, it's several connected computers where each computer have a set of RAM memory and a number of cores. And these individual computers are called nodes. So there are some login nodes where you come when you are logging in with SSH or via ThinLink, and then you will be down here in the login nodes. Here you can do day-to-day work, move files and read files and such, and do some easy analysis. But if you need to do more intense computing, and for instance, using several cores, like parallel computing, or using lots of memory, then you book calculation nodes or compute nodes, book or allocate, basically. And the good, so there then you perform your work on one or several nodes together. The good thing here is that also these nodes are connected to a central storage. So you can still work in your ordinary file system and do your high performance work. So everything is interconnected in a good way. There are more information in the pre-requirements. For instance, we can actually mention now that on RACCAM there are 20 cores per node. And quite often you are limited to run a job within a node, because otherwise you need some, you call it MPI, that we will talk about in the afternoon. With MPI, you can use several nodes altogether, but otherwise you're limited to only one node. So that means that on RACCAM you can use up to 20 cores. On HPC2N, I think it's 28 on Kebnekaise.
Yes, that is correct.
Yes. And you can use all of them with the threading, or can you only use 14?
You can use all of them.
Yeah.
And there's also the newer nodes, the Zen 3 one, which has a little bit more cores, but we don't have very many of those yet, so it's mainly the ones we had before, so not much difference.
Yeah. Okay, so here are some similarities and differences, but we will see during the day here what are the differences. So I won't go through it. Yes. And yes, I should mention that we have our applications in a modular system, which we will look at in a minute or half an hour. This is called a module system. So we should differentiate this between the module system and like Python modules or Julia modules or packages. So in the course here, we call the libraries for Julia. We call those packages, whereas we use module for the software modules, like Julia module, R module, Python module, GCC module could be as well. So please now try to log in, and it's up to you if you want to use the ThinLink or if you use a terminal. So you see here that we have one tab for APC2N and one for UPPMAX. So please choose the one that will work for you. So please try to log in, and also, if you have not already done so, create a working directory where you can code along. So you could work in your home directory as well, but we show now how to use project folders, because there is where you should do your research in the future, in the project folders, because it is bigger, you have more storage, and you can also have more files compared to in your home directory. So it's a good practice to have at least project-related things in a project folder. So please let me know when you're finished. You can use up sign or green check mark or something like that. Yeah, so some of you did this yesterday, so it's the same thing. So let you work a little bit in the background. And if you had any problems, please let my colleagues know. Otherwise, I will go now to the next section, which is Julia lessons in the menu here. An introduction to Julia. And I will say some words before I give the word to Pedro. I post a link, chat. Yes, so we will learn how to load Julia modules and site installed Julia packages. A little bit, you will more learn how to actually install your own packages actually, and using environments, which is very good. Making batch scripts, which is basically telling a compute node to run your work. And also looking at parallelization using GPUs and machine learning. And when you have logged in and you have a folder with your name, you can copy today's tarball for the Julia exercises. These are here, but let's see. Yes, so basically you download them. I would basically do these steps where you replace your name with your name, and a little bit different on the Kebnekaise with the path here with no backup. So this will go to your project folder, your personal. This will copy the tar file with the exercises, and then you untar it which opens it, and you can reach the different files. And you can also check what is in there with this tree command. Because I think the tree is installed now on Kebnekaise.
It's not, but
It's not. Okay.
I wrote somewhere, I think that is under the R session for tomorrow, but I wrote how you can install a tree for yourself. I mean, how you do that when you're not root.
Yeah, so that is not necessary. So instead of tree, you can use just the ls, which means list of the content of the Julia directory. Yes. Maybe I should actually show how I log in. So I will use something called Mobax term because I'm a Windows user right now. Okay. Okay, things are very slow.
We're also not seeing your terminal window. We are only seeing still there. Okay.
Yes, you see, it's a little bit okay. Well, the Zoom windows are in the way. So yes. So I do SSH -x, my name, and I will log in now to UPPMAX because that's my home. Account uppmax.u.se. And I use this -x to have some graphics, but it is not needed for now. Okay, let me do small screen. So here we are. I'm on Rackham, and you can see that I'm in the login node by this one. And I will now go to the project folder, and we have this one, and see what's in. Okay. So should be R, this one. Yes, here we are. And we have here Julia exercises. So I can try this out. Why don't I see the screen there? CD Björn. I will make a directory. I will go inside it. It's empty. And I will copy what is in the parent directory, Julia exercise tar, and dot is for that I want to copy this file to the present directory. So now it's there, and I untar it, which was this extract, xvf. I can also see that what I'm doing. So here I am, and I can now list what's inside the Julia. And you see that we have several exercises today and some solutions as well. Okay. Before we continue, please.
So can you see the website that says Julia and also the terminals?
Yes.
Okay, that's good. Yes, today we will talk about Julia, yes, only. So as in a similar format as we did yesterday for Python, right? So so you may know already that Julia is a relatively new programming language, launched fiercely in 2018. And it's new compared to other languages like Fortran, C, C++ that are from the 70s, right? And the goal of this language is twofold, right? One is for productivity, fast deployment, fast prototyping. So if you want to write some fast code, right, that you don't need to compile, so to speak, and to invest a lot of time, then Julia is a good option. And also for performance, right? Because here you can do fast numerical computations in comparison to pure Python, right? So this twofold, yes, feature here gives rise to the so-called two-language problem, right? That is found in the standard languages R, Python, where you can achieve a good productivity, right? You can write fast scripts. Yes, you don't need to invest a lot of time in writing code. But the drawback is that these scripts are not performant in general, right? Or if you want to write some performant code, then you go to some lower level language like Fortran and C++. But here you need to deal with the compiling step, right? So it's tedious if you are developing big codes, yeah? Especially for big codes, because of the compilation time, for instance. So because of these two feature problems, right? So Julia came out, and it tries to make a bridge, right, between these two big topics. So that's why I painted here that Julia is trying to fill the gap between these two set of languages. So one solution here, for instance, for Python and R to make a performant code is to use some interfaces to faster languages. But this creates the issue that you then need to support not only Python or R, but also you need to import libraries that also support other languages. You also need to learn other languages and so on. So Julia is offering to write a code in Julia itself that is performant, that can achieve a fast prototyping. So this is the basic idea of Julia, right? And here I provide you with a short demo, right? So you can follow, but this is just a demo. It's not a type alone because it can take some time, especially if there are some errors, right? So later on, you can try it yourself. And if you are more experienced, you can also try that. So these are the steps for UPPMAX and HPC2N. So I can show you briefly. For HPC2N, you can search here for Julia on the command line, So this session here, this first block is for HPC2N. The second here is for Rackham, UPPMAX, and this third one is for Dardel at KTH, right? So here now I am moving in HPC2N. So here you can search for Julia, ML Spider Julia. And you can see here the different versions that are installed, right? So we will be using the last one. So we need to check for the dependencies of Julia in this case. You check for the dependencies with ML Spider and then the name of the Julia version. And it says that you can load it directly. So which means that you don't need to load any other compiler, toolchain, any other software. So in principle, you can do it ML, Spider, and the Julia version, and Julia should be there, right? In the case of UPPMAX, there are also different versions of Julia. As you can see here, ML Spider, Julia, and you can see that it goes from the 1.0 to the 9.3, but in the present case, we will use the 8.5. So here in UPPMAX, you can type here Julia, ML Julia, and 1.8.5. So it should be there now, right? So we can check if it is there. If you type on the command line Julia, and then you get the Julia prompt. UPPMAX, you can type here Julia, you get the Julia prompt. Yeah. So PDC, you may know how to log in into Dardel. You can identify yourself with the SSH key. For instance, this is what I did. And here you do exactly the same ML Spider, Julia. And it shows you the different versions, right? So the closest one, they don't have the 1.8.5. The closest one is this one. So I will select this. And then I will search for the dependencies because some software require extra modules, as you can see here. So for PDC, we need to load this module first, yeah? PDC 222.6. So this is what we do here, PDC, and then the Julia version that we wanted, this one, 1.8.2. Now it does something, and then we can see if it is there. So you can see that Julia prompt is here, right? So now we can start working here in a interactive mode, so to speak, right? So we can do something simple like a calculator, right? So the important point in Julia is that it uses several modes. And the first one and the most basic one that you are seeing at this moment is the so-called Julian mode, where you get this prompt here that says Julia and this symbol with the greater than. And here you can control Julia, yes, and execute some commands. But also Julia has other modes, right? Besides the Julian mode. So for instance, if you press at this point here, this key, the semicolon, I think. If you press the semicolon, let me see, where is my semicolon? No, it's not my semicolon. Interesting. I will change my keyword. I press the semicolon. Should be here. And then you can see that if I press this key, then the prompt changes to the so-called shell mode, right? And here you can execute Linux commands. Like for instance, if I type ls, so then it lists the files, right? So notice that if you are working in Windows, especially Windows, you could get a different output, yeah, depending on what shell you are using. PowerShell, for instance, seems to be integrated, yeah, but other shells, Mobile Xterm, I don't remember. So it depends on what shell you're using, yeah. There are some ways to make this working, yes, but the Linux commands may not be available, yes, depending on the shell that you're using. So this is the so-called shell mode. So if you want to return to the Julian mode, you press the backspace, and then you are back to the Julian mode. So the third mode is called the package mode. And here you can get to this mode if you press this key here, the right bracket. So what is the right bracket here? Let me see. I will change my keyword. So if you press the right bracket here, then you see that the prompt changed again. So now I can see that it says a PKJ, which is a package mode. And here we can add packages and delete packages and make and know about the status. So if we want to know the status of the current environment, for instance, we can type the status, and if it tells you what packages are installed in the current environment. So in the package mode, we just write a status. So this can be also done in the Julian mode if we type, for instance, pkg.status. But here we need to type pkg and then dot status and this parenthesis. So and first of all, in order to use pkg, we need to import the module pkg, which is the package, right? And then we can know what packages are installed. But if you do that on the package mode, it is automatic. So you can type here status and you get the same output. Yeah. So there are also other commands that you can type in package mode. Yeah, and that makes the things easier. Also, if we want to know more information, yes, about any command, then we can go to the help mode. This is another mode, yes. And this can be obtained if we type the question mark symbol. And then you see that it changes to this prompt here, help. And then you can type, for instance, some function name or some command that you want to know more about. For instance, ans, and it retrieves some information that it has for this variable here. Yes. So these are the modes in Julia, right? And here there are some features that are taken and adapted from the Julia documentation. You can read more about in the Julia documentation. This program is well documented. So Julia has a good base library. So it means that So the most basic commands, right? The most common ones are highly optimized and they are very well implemented. So you don't need to install them. So once you install the Julia, then the base library should be there. Yes. So it has a good performance, approaching, or in some cases, it is faster than statically compiled languages like C. So Julia is modular and self-contained, and this allows you to create big projects, yes, by using packages that other persons have already created, because they can be integrated in your Julia code easily. So it's a rich language, and it offers different types for constructing and describing objects. So Julia is based on the type, yes, of your variables and functions. So basically, here you need to master what is a type, yes, in a command in a programming language. So it's fast-growing community of users and developers. So shortcomings, because it's a relatively new language, the libraries ecosystem is not as big as in Python or R. So in these two languages here, there are already different versions, even different versions of the packages that can solve the same problem. So you can choose what you can use, but in Julia, sometimes that is not well developed. So currently, using Julia for simple tasks, and for instance, opening files and writing some short text or plotting is not as efficient as if you use, for instance, AWK, grep, or Fortran, Rust, C++. This is more specific if you know MPI, right? So this is just an impression that I had. So if you want to write some initial code that runs fast compared to Python, for instance, then Julia is an alternative. However, if you want to optimize further your code and get a very efficient code in comparison to Fortran or C++, then you need to invest more time, right, in learning the features of the language of Julia. Yeah. So here is the documentation page for UPPMAX, and here is the documentation page for HPC2N. Here there are some pages that you can check. Interestingly here, this Slack channel is where you can join and share your questions, share your experiences with Julia, and this community is very active. This is a short video on Julia that we made at HPC2N previously from one of the developers of Julia. And here there is some additional material, yes, where you can learn more about it. This is the documentation.